Alright, if one root of the polynomial p of x equals 2x cubed plus x squared minus 7x minus 6 is 2, find the sum of the remaining roots. So we know if 2 is a root, we can divide synthetically by that using just the coefficients 2, 1, negative 7, negative 6. We should get a 0 remainder here when we do this division. Bring the 2 down, multiply by 2 you get 4, add you get 5, 5 times 2 is 10, add you get 3, 3 times 2 is 6, add you get 0. That confirms that 2 is a root. Okay? The other two roots are going to be the solutions to this depressed equation. It's going to be 1 degree less than we started with. It was cubic, so now this will be 2x squared plus 5x plus 3 equals 0. We can factor this one. If I give myself room. Put the 3 there and the 1 there. And we get 2x plus 3 times x plus 1 is the factorization. And setting this equal to 0, we get, I'm going to skip a step here, we get negative 3 halves, and we get negative 1. The sum of these two roots would be negative 5 halves. That's letter C. Okay? Find k, so that x plus 3 is a factor of this polynomial. Well, it's in the middle of this whole polynomial. We've got to find the right value of k that makes that a factor. Well, we know that if negative 3 is going to be a factor, or if 3, the factor, if x plus 3 is going to be a factor, we know that negative 3 would make a 0 remainder. So you could go through the synthetic division, use synthetic division for this one, using negative 3 as your index, and see what it would take to make the remainder 0. There's nothing wrong with that. Let's try that way. I might try this a different way later too. 1, 1, k. Remember, looking for missing powers, but it goes 4, 3, 2, 1, 0. So there's no missing powers. But the coefficient on the squared term is k, then the linear coefficient is negative 1, and then positive 6. And we know we got to make that 0. Okay? So let's see what we can figure out what has to go in place of k. We know that has to be 1. 1 times negative 3 is negative 3. 1 plus negative 3 is negative 2. Negative 2 times negative 3 is positive 6. So this now would be k plus 6 when we add in that column. Alright? We can keep going. This k plus 6 times negative 3 is negative 3k minus 18. If we add there, we get negative 3k minus 19. And if you multiply by negative 3 there, now you get positive 9k plus 57, and 6 plus 9k plus 57 has to equal 0. 9k plus 63, or I can subtract 63 from both sides to get that. So 9k must be negative 63, k must be negative 7. That's one way to do it. Now I'm just going to stick with that. Yes or no question. You got to like that. Is x plus 1 a factor of the polynomial p of x equals x to the 129th plus 3x to the 52nd minus 3x to the 6th plus x plus 2? Could use synthetic division. Have fun with that. But there's got to be a quicker way, right? Because we got to fill in all those zeros for missing powers. Well, we know also that the factor theorem says that if x plus 1 is a factor, that means that the same value you would use as your index. If you did synthetic division, dividing by x plus 1, you'd use negative 1 as your index. If you use that negative 1 and just plug it in for x, if it makes a 0, if it makes the whole function equal 0, that means it would make the remainder 0. So you'd have a factor. So we just want to see if plugging in negative 1 for everywhere for x would make a 0 for the function. Well, negative 1 to an odd power is negative 1. Negative 1 to an even power is positive 1 times 3 is 3. Negative 1 to an even power is 1 times negative 3 is negative 3. And then you got minus 1 and plus 2. We add all these up. Let's see. I've got 3 minus 3 cancel out. Negative 1 minus 1 is negative 2 plus 2 is 0. So, yes, I would say that x plus 1 is a factor. Find the cubic equation that has -3 and I squared to 2 as roots. Well, we know that if it's cubic, we know there's 3 roots total, and if one of them is imaginary, its conjugate is also a root. Imaginary roots always come in conjugate pairs, so if I squared to 2 is a root, -I squared to 2 is also a root. So we really have all 3 roots. We want to work backwards and build the equation that produces these roots. Well, working with -3, the factor that produces -3 is easy. That's just x plus 3. And then, using the shortcut that we learned in Chapter 7, if I squared to 2 is a root, -I squared to 2 is a root, you might be able to picture what that factor would have to be. But if not, you can always go back to the x squared minus the sum of the roots times x plus the product of the roots. So if you use those as the 2 roots, x squared, the sum of those roots is 0, so that's all going to be 0, so minus 0x, plus the product of the roots. If you multiply those together, you get -1 I squared times 2. But I squared is -1, so it makes it positive 2. And that's the other factor, x squared plus 2. That would produce I squared to 2 and -I squared to 2 as roots. So you've got to multiply these together now, and you'll get your cubic that produces all 3 roots. We just FOIL this out, x cubed, and then I'm going to go inside first because it gives us our squared term, 3x squared plus 2x and then plus 6. I'm looking for that one, and it is choice A for number 8. Alright, let's just keep going. Find the eccentricity of the ellipse. Ooh, fun stuff. Okay, we got to get this into the different form. We're going to group the x's. We're going to group the y's. And we're going to move the constant to the other side by subtracting the 100. Then before I can complete the square, I'm going to factor out the coefficient on those squared terms. Leave some space to complete the square. Do the same thing with the y's. Leave some space. Now I'm going to complete the square. Half of -4 is -2. When you square that, you get +4. But the actual value I've added is 9 times 4. So I've added 36, so I've got to balance it off with 36 on the other side. Half of 10 is 5. 5 squared is 25. I can write a 25 there, but actually what I've added is 100. So now I have 9, and this is a perfect square trinomial. The factor is x minus 2 squared. And this is 4 times the quantity. This will be y plus 5 squared. And this is going to be 36 on the right side. I'm going to make that right side a +1 by dividing everything by 36. Dividing everything by 36 and reducing where possible. Gives me that. So, find the eccentricity. We need to know what C is. And we need to know what A is, because eccentricity is C over A. Okay? With the ellipse, the larger denominator is A squared. Remember that with a hyperbola, it's always the first fraction's denominator is A squared, not necessarily the bigger one. But with ellipses, it's the bigger denominator. So A is 9. And with the relationship with the ellipse, the book teaches it a little differently. I remember it as A squared equals B squared plus C squared. It's easy for me to remember that A is the greatest value of the ellipse because the focus is inside the ellipse, so I know that C is less than A. So I know that A squared is the biggest one. I make it the hypotenuse of that Pythagorean theorem relationship. So A squared is 9, B squared is 4, C squared must be 5. So C is the square root of 5. And A is 3. So the eccentricity would be square root of 5 over 3. Choice E. Okay? Number 10. Find the distance between the center of the ellipse described above, oh boy, and in the center of the hyperbola here. So let's go back to this. The center would be 2, -5. Okay, I'm going to bring that over to the next problem. 2, -5. And I've got to find the distance between that center and the center of this hyperbola. So let's do the same thing with the hyperbola. Group the x's, group the y's, move the constant to the other side. This way it'll be a positive 1. Factor out 4 from the x terms. Factor out a negative 1 from the y terms. This is the trickiest kind here. And you have to factor out a negative there. Let's complete the square. Half of 2 is 1. Squared is still 1. 4 times 1, though, is 4. Half of 2 is 1. 1 squared is still 1, but negative 1 times that is negative 1. So, we end up with 4 times the quantity x plus 1 squared minus y plus 1 squared equals 4. And divide by 4, and you can get this set up, but really, I don't really need to do all that. All I need to know is the center, which is going to be hk, negative 1, negative 1, right? That's really all I need. So now I'm looking for the distance between 2, negative 5, and negative 1, negative 1. The distance is just like, you don't have to memorize the distance formula necessarily, but you can. If you haven't memorized, use it. But if you picture these 2 points, 1, negative 1, and 2, negative 5, oh boy. Let's see. The distance is just the diagonal between those. So basically, it's just the Pythagorean theorem. This is the distance of 1. This is the distance of 4. 1 squared plus 4 squared is 17. Square root of that is square root of 17. Oops, I did something wrong. Let's see. Negative 1, negative 1. Never mind. Negative 1, negative 1. This over here is the center. So I'm looking for this distance. And that distance there, the horizontal distance is now 1, 2, 3, 3. And the vertical distance is 4. That's easier. 3, 4, 5. The distance is 5. Choice A. Sorry about the botch there. Okay? Have fun. How many solutions are there to this equation, to this system? Well, if you want to do it the quickest way, you don't actually have to find the solutions, just how many there are. This top one's a circle with a radius of 3 centered at the origin. So, something like that. Not really, but kind of. Okay? That's a circle. Remember how to graph the parabola. Since y is the squared term, it's going to open sideways. We're going to look to try to get it in the form of x minus h equals a times the quantity y minus k squared. So, I'm going to try to get the x terms on one side. All I got to do is to subtract 4 and subtract the x and y squared from both sides. So going from this form to this one, then divide by 1/2 or divide by 2 or multiply by 1/2. So you get x minus 2 equals negative 1/2 y squared. And this means the parabola opening to the left, because your a value is negative and it's y that's squared, not x. So no, it doesn't open up and down, it opens left or right. Opens left with a vertex at the point 2, 0. And that's really enough information for us to figure out how many solutions there are. If it has a vertex at 2, 0 and opens to the left, it doesn't even matter how wide it is. It's going to touch the circle in 2 different places. This one has two solutions. Alright? Logarithms. Missed them already, don't you? The base 3 log of x, that's f of x. And g of x equals 4 to the x minus 2. Find g inverse of f of 81. With compositions of functions, we work inside out. Figure out what f of 81 is first. F of 81 is the base 3 log of 81. In other words, what power does 3 need to be raised to in order to equal 81? Well, 3 times 3, or 3 times 3 times 3 is 9, times 3 again is 27, times 3 again is 81. So that's equal to 4. So that's 4. Find g inverse of 4. Now remember the trick, when you're asked to find g inverse of something, go to the rule for g of x, but don't plug in that quantity. Don't plug the 4 in for x, plug the 4 in for g of x. So now you get 4 equals 4 to the x minus 2, and you're solving for x. Well, that is 4 to the first. If this is going to be 1, that means x has to be 3. If x is 3, you get 4 to the first on both sides, so x must be 3. And that's really what you're evaluating there. Okay? 13. Solve for x. It's an exponential equation with a base of e. And we can't get the bases to be the same. We take the log of both sides, but because one of the bases is e, we take the natural log of both sides. And now we try to solve for x. One of the properties of logarithms says we can take the whole exponent and move it out in front. We can make this 3x plus 1 times the natural log of e equals the natural log of 40. But the natural log of e is just 1, so that's not even necessary there. Subtract 1 from both sides. So you subtract 1 to try to get x by itself. Remember though, so this is not the log of 39, natural log of 39. The natural log of 40 is a number. You're subtracting 1 from that number, but you just leave it this way. Then you divide by 3. So you look for one answer up there that looks like this. And there is one. It's letter A. That should be an easy one. Okay? If the tangent of theta is 12/5 and cosine of theta is negative, find the sine of 2 theta. I'm going to start by expanding this formula. Sine of 2 theta, and you'll have the formula sheet, is 2 sine of theta cosine of theta. Okay? So I need to know what the sine of theta is and the cosine of theta is. I don't have either of those, but I have enough information to find it because I know that the tangent of theta is 12/5 and the cosine is negative. Well, the tangent is positive here, and tangent is only positive in the first and third quadrants. But if the cosine is negative, it can't be the first quadrant, it must be the third quadrant. So this angle in question is a third quadrant angle, and the tangent is opposite over adjacent, so 12/5. But I'm going to make both of those negative because we're moving to the left, so that's negative in the x direction, and we're moving down, which is negative in the y direction. So negatives on both of those. And then the missing part of that triangle, 5, 12, 13. So from that diagram, we can tell that the cosine of theta, adjacent over hypotenuse,
come to attendance. Mary Bowman, please come to attendance.
Cosine of theta would be negative 5/13, and the sine of theta is opposite over hypotenuse, negative 12/13. So now we just plug that in here. Negative 12/13 for the sine, negative 5/13 for the cosine. Negative times negative is positive. 60 times 2 is 120 over 169. There we go, letter C. Piece of cake. Alright, let's try this one. Find the maximum value of f of x equals 2 minus 4 times the sine of x. Alright, well, if you think about what values could be plugged in there for the sine of x. Sine of x, if you remember your trig stuff, the biggest value we can ever get for the sine of x is positive 1. The smallest is negative 1. So, what value would make this function as big as possible? Well, because we're multiplying it by negative 4, if we had a negative 1, it would actually create the biggest possible value. If we plugged in negative 1 for the sine of x, negative 4 times negative 1 is positive 4. 2 plus 4 is 6. And that's the biggest value you can ever get for this function, is if sine is actually negative, because you're multiplying it by a negative. If this was a plus 4, then you'd want this to be a positive 1 to maximize it. But think about the biggest or smallest values the sine can ever be, and use those and kind of be your guide from that. So 6 is your answer. Easy one if you remember the basics about trig. Okay, triangle XYZ. If x is 2 units long, y is 3 units long, and angle z is 120 degrees, find side z. This is a law of cosines problem. How do I know? Because I have 2 sides in the included angle. If you draw a triangle XYZ, you label 2 sides x and y. Remember, the angles opposite them are named the same one. So angle z is the angle between x and y. So you have side, angle, side is what you know. So to find the other side, we're going to use the generic formula, c squared equals a squared plus b squared minus 2ab times the cosine of c. That's the generic formula that you have to employ here. A and B represent the known sides. Angle C is the known angle. So sides, actually it's side C this time. The side opposite the known angle would be side Z. Would equal 2 squared plus 3 squared. Those are the 2 known sides. Doesn't matter what order you put them in there. minus 2 times 2 times 3 times the cosine of the known angle, which is 120. Don't even need a calculator for this one, because the cosine of 120 is a known quantity. Cosine of 120 is actually negative 1/2 from our automatics. Okay? So now, if you have a negative 2 times 2 times 3 times negative 1/2 is going to be plus, and I'm going to cancel these out. They multiply to be positive 1. So it ends up being 4 plus 9 plus 6. That's 19. Z squared is 19. So Z would be the square root of 19. And that's choice D. Okay? Fun problem here. In triangle ABC, the sine of angle A is 2/7. The sine of angle B is 3/4. And side B is 14. Find side A. This is presented a whole different way. You haven't seen one like this. But it really is just using law of sines. We don't know directly what angle A is, but we know the sine of angle A, which is even better, because we know in the law of sines, the sine of A over A equals the sine of B over B. So this is even better than knowing the angle. We're already given the sine of the angle, it's 2/7. So plug that in for the sine of A. Plug this in for the sine of B, 3/4. Side B is 14. Find side A. Easy enough. Cross products, right? So 14 times 2/7 equals 3/4 times A. Well, 14 times 2/7 is 4. Multiply by 4/3 to get A by itself. 4's cancel. All we have left on the right side is A. 16/3 is our A value. And that's letter B. Okay? 3 more. We're almost there. Which of these is not like the other ones? Sesame Street. Alright? You don't know really where to start with this one, except let's try to, simplify each one. What's 64 to the 1/3? Well, that's the cube root of 64, which is 4, because 4 cubed is 64. So A is 4. B, 1/3 the natural log of 3e to the 4th. Well, let's figure out the natural log of 3e to the 4th. Remember that if you have a multiplier out in front here, 1/3 can be moved to the exponent. So this would be the same thing as natural log of 3e to the 4th raised to the 1/3 power, or 3 natural log of 3e to the 4/3. Alright? Or, then, again, you could move it back out here. Actually, I got to start this one over. I did this. Hold on. Alright, 1/3 natural log. Okay. We're going to start this over. We're going to pause.